So this is G484 homework booklet 22. So we've got a diagram representing the planet Jupiter, and we're asked to add gravitational field lines to it. So remember, the things you know about gravitational field lines is they show the direction of the force, and how densely packed they are tells you something about the field strength. All we need really to do here is to think about the direction. Everything gets pulled towards the centre, and so the lines are all radial from the centre of the planet, and with central arrows pointing towards the centre of the planet. Arrows, at least one indicating directions towards the planet for 1 mark, and all lines looking as though they'd meet at the centre, judged by I, 1 mark. So fairly straightforward. If they were looking for more detail, it is important that in a circle here these are evenly spaced out, so these are separated out by even angles. I've tried to do those at 45 degrees because the field strength isn't different at different points around there. Interesting to note, and really important one to look out for, that command word draw, because there's no answer slot because it's going on the diagram. It's dead easy to miss out and not do that question, so do be careful of that. Jupiter's got that radius and the gravitational field strength at that distance, so this is the technique of weighing a planet using the field strength. Crucially, show. So we've got show that the mass of Jupiter is about 2 × 10⁻²7. So I'm going to start by saying that the gravitational field strength, M, or the gravitational force, sorry, mg, is equal to the more general gravitational force, gm, m upon r squared. And then rearranging that, again, I've cancelled off the little m's. There you go. Bye bye little m. Bye bye little m. And then multiplied by r squared divided by g. It's a show question, so they actually quite explicitly wanted that equation shown out in full. Put the numbers in, get the answer, no problem. Show it's about, so I've calculated it to one more significant figure than that 2 there, so that's 2 single significant figures, so I've given my answer to 2 significant figures. And then calculate the average density of Jupiter. Essentially this is a bit of G481 synopticity. I've got to calculate the volume. Volume is 4/3 pi r cubed. That is in the formula booklet if you can never remember when it's 4/3 pi r cubed and 4 pi r squared, which is the surface area. So you've got access to that. You can calculate the volume, and then you're just doing the mass that you've calculated divided by that volume, and we end up at 1250 kilograms. If you used the 2 that you were told it was about, because you couldn't do part 1, you actually end up at 1312 kilograms per cubic meter, but you do get the full marks. So fairly straightforward end to the question there. G484 homework booklet question 22.